Why are there different options for creating bootable USB compared to a CD? So when creating a bootable CD, it was really simple in my opinion. All you needed to do was burn an ISO file to a disk and it was bootable. Now with the USB drives you have lots more options. Could someone explain the difference needed between the two? Maybe give a brief overview of the different options.
Rufus developer here. First of all, a lot of the options you list are only be listed when running Rufus in advanced mode, i.e. when the advanced options section is displayed, because they are intended for people who already know what they are about. To start with, you have to understand that the ISO format was never designed for USB boot. ISO is a one-to-one copy of an optical disc, and optical disc media are very different from USB media, both in terms of how their bootloader should be structured, what file system they use, how they are partitioned, they aren't, and so on. So, if you have an ISO, you cannot simply do within USB what you can do for an optical disc, which is read every single byte from the ISO and copy it as is, in sequence, onto the disk, i.e. what CD/DVD burner applications do when writing an ISO. That's not to say that this kind of one-to-one copy cannot exist for USB, just that, one-to-one copies of USB media will be completely different from one-to-one copies of optical disc media and, outside of using ISO hybrid images, that are crafted to work as both one-to-one copies of disc and optical, are therefore not interchangeable. For the record, in Rufus terminology, a one-to-one copy of USB media is called a DD image. You'll see that option in the list, and some distributions, like Freebs or Raspbian, actually provide DD images for USB installation, alongside ISOs for CD/DVD installation. Thus, we have established that ISO images are actually poorly suited to create bootable USB media, because they are the equivalent of providing a round peg in order to fit a smaller square hole, and therefore, the round peg must be altered in order to fit. Now you may be wondering why, if bootable ISOs are so poorly suited for that. Most OS distributors out there provide ISO images instead of DD images. Well, outside of historical reasons, one of the issues of DD images is that, because they are a partitioned file system, then if you create a one-to-one copy on USB media, and your media is larger than the one from the person who created the image, then you will end up with the apparent capacity of your media reduced to the size of the one from the original DD image. Also, whereas optical discs, and therefore ISOs, can only ever use one of two file systems, ISO 9660 or UDF, all of which have been very well supported in all major OCs for a very long time, which allows you to take a peek at the image content before or after you use it. DD images can literally use any of the thousands of different file systems that exist, which means that, even after you create your bootable USB, you may not be able to actually see any content on it until you boot. For instance, this will be the case if you use the Freebs USB images on Windows. Once the USB has been created, Windows will be unable to access any content on it, until you reformat. This is why OS providers tend to want to stick with ISOs where possible, as it, usually, provides a better user experience across all OCs. But that also means that some conversion must, usually, occur, so that a round ISO peg can fit nicely into the smaller square hole that is in USB flash drive. How does that relate to the list options? We're coming to that. One of the first thing that usually needs to go is the ISO 9660 or UDF file system that ISOs use. Most of the time, this means extracting and copying all the files from the ISO onto a FAT32 or NTFS file system, which is what bootable USB flash drives tend to use. But of course that means that whoever created the ISO system must have taken some provision to support FAT32 or NTFS as a file system for live or installation, which not all people, especially the ones who rely a bit too much on ISO hybrid, tend to do. Then, there is the actual bootloader itself, i.e. the first bit of code that executes when a computer boots from USB. Unfortunately, HDD/USB and ISO bootloaders are very different beasts, and the BIOS or UEFI firmware also treat USB and optical media very differently during boot. So you can't usually take the bootloader from the ISO, which would usually be an L-Torito bootloader, copy it to USB, and expect that USB to boot. And this is the part that is relevant to our list options, because Rufus will have to provide a relevant bootloader piece that it simply can't obtain from the ISO. If we are dealing with a Linux-based ISO, then chances are we'll use Grub 2.0 or SysLinux, so Rufus includes the ability to install an USB version of Grub or SysLinux, since the ISO usually only contains the ISO-specific version of those. Now, this is usually done automatically when you select ISO image and open an ISO, as Rufus is smart enough to detect what kind of conversion it needs to apply. But if you want to play around, Rufus gives you the choice to also install some blank bootloaders that enable you to boot to a Grub or SysLinux prompt. From there, if you are familiar with these types of bootloaders, you can create/test your own config files and try your very own SysLinux or Grub-based custom boot process, because, at this stage, you only have to copy/edit files on the USB to do that. So, we can now go around the options you find in the list. MS-DOS. This creates a blank version of MS-DOS. Windows Me Edition, which means you'll boot to an MS-DOS prompt, and that's it. If you want to run a DOS application, you'll need to copy it. Note that this option is only available on Windows 8.1 or earlier, but not Windows 10 since Microsoft removed the DOS installation files from Windows, and only Microsoft can redistribute these files. FreeDOS. This creates a blank version of FreeDOS. FreeDOS is a free software version of MS-DOS, which is fully compatible with MS-DOS, but has also the advantage of being open source. As opposed to MS-DOS, anyone can redistribute FreeDOS, so the FreeDOS boot files are included in Rufus. ISO image. This is the option you should use if you have a bootable ISO and want to convert it to bootable USB. Note that, because a conversion, usually, needs to occur, and there are zillions of ways to create a bootable ISO, there's no guarantee that Rufus will be able to convert it to USB. But it will always tell you if that is the case. DD image. This is the method you should use if you have a bootable disk image, such as the ones provided by Freebs, Raspbian and so on. .vhd are also supported, which is Microsoft's version of a DD image, as well as compression, .gs, .zip, .bz2, .xe, .z. The four options above are the ones you will see in regular mode. If you run Rufus in advanced mode, you will also have the following choices. SysLinux x.yz installs a blank SysLinux. This URL, bootloader, will get you to a SysLinux prompt and not much else. You are supposed to know what you need to do from here. Grub/grub4DOS, same as above, but for grub/grub4DOS respectively, will get you to a grub prompt, up to you to figure out the rest. Reactos installs a Reactos bootloader. This is experimental, since, last time I checked, Reactos didn't boot that well from USB. It's there because it was easy to add, in the hope that it can help with Reactos development. UEFI NTFS. This requires NTFS to be selected as the file system. Installs a blank UEFI NTFS bootloader. This enables booting from NTFS in pure UEFI mode, i.e. not CSM, on UEFI platforms that do not include an NTFS driver. Because it's blank, you'll need to copy your own /EFI/boot/bootia32.EFI or /EFI/boot/boot64.EFI onto the NTFS partition for that to be useful. UEFI NTFS is automatically used by Rufus to work around the 4 GB maximum file size of FAT32, which, for instance, allows the installation of Microsoft Server 2016 in UEFI mode, without having to split its 4.7 GB install.vim file. Hope that helps. P.S. This is a simplified overview, so I hope people won't start nitpicking on aspects that were deliberately dumbed down or kept silent, such as that. Yes, I know it is possible to have USB flash drives without partitions. Yes, it is also possible to have USB and optical use the same file system, and yes, some boot processes have the capability to extend the partition size to the USB size to solve the lower apparent capacity issue.
Rufus is a formatting tool for USB drives, i.e. it can be used even if you aren't interested in making bootable drives. The top part is for this general formatting, the bottom part is specific for adding content. CDS normally don't have the option of using different file systems and partitions. CDS as a medium, by convention, have a single partition with the ISO 9660 or UDF file system and some standard block size. Other formatting is possible with the right tools, but Rufus only supports formatting USB drives. Even if you managed to create a CD with an MBR in various file systems, it probably wouldn't be bootable because the firmware doesn't expect it. BIOS and UEFI treat bootable CDS similarly, I think, but they require different formatting for USB drives. To simplify, UEFI requires a FAT partition and EFI files. BIOS needs the initial boot code to reside in an MBR partition table, doesn't care about file system type. This means smart formatting software should include options for BIOS and UEFI and process the image file appropriately. I believe this is what happens when you select ISO image in the drop-down list. But that drop-down list below isn't really USB specific. The equivalent of an old-school CD burn is DD image, probably related to the Unix DD command. The other options allow adding bootloader programs. This is useful for two reasons. You might not have boot code in your image file for booting. Just because an image is bootable for CDS doesn't mean it contains boot code for a USB drive, though hybrid images do exist. Another bootloader might offer options you prefer, or does a better/faster job of loading your OS. In theory, a CD burner could also offer the option to overwrite/add a bootloader like those in your drop-down list, i.e. a Rufus for CDS, but I don't know if it exists. The ISO option in that list probably uses DD mode internally, if your firmware target matches the properties of your image. But that is speculation on my part.
In general, you don't have to bother about that. These options typically are special options, or specific bootloaders you want in specific cases. For some reason I have a different set of options, but ISO image and DD image are the default options. Syslinux and Grub are Linux bootloaders you can then set up to chainload something else. UEFI NTFS sets it up as a UEFI bootable NTFS partition for whatever use you may have. I don't have the MS-DOS. FreeDOS makes a basic FreeDOS bootable USB, and ReactOS asks you for an ISO. Practically speaking, all you need to do is click on that little disk icon to the right, point it at the ISO and let Rufus take care of it. As for why it's so complex, with burning an ISO, you are literally just making a bit-perfect copy. With USB boot, there's additional steps, which Rufus hides beautifully. For example, you can pick different system firmware options, classic BIOS, or UEFI, which matters sometimes. You can pick a file system,
though FAT32 is always a safe option. Contrast this to which drive do you want to burn it to.
I can't help but notice that your comparison of burning an ISO image to formatting and preparing a USB flash drive is not proportionate. You must either compare burning an ISO to disk to writing a VHD to a USB flash drive, or compare formatting and preparing a bootable disk with narrow-burning ROM to formatting and preparing a bootable USB flash drive. In the first case, both ISO and VHD have formatted and prepared structure that only needs be replicated to the appropriate medium. In the second case, you have to face various complex choices regarding the bootable CD is narrow burning ROM, like emulation method, floppy, HDD, no emulation, and boot sector start offset. Now Rufus can not only format and prepare a bootable USB flash drive, it can pick an ISO image, strip its disk-related structure, extract its file, dump them on the USB flash drive and then add facilities to make the USB flash drive bootable. That's a great feat. Don't underestimate it.
If you want to support the channel, please consider subscribing.